And I don't think we need to see us all the time. So I'm just going to click on you.
That's good.
And I think we're ready to go. So would you, I don't think Jon needs much more of an introduction than to say, welcome Jon Skeet, everyone.
Thank you, folks. Hopefully this is legible enough in terms of the font size. This is what I'll be doing today. It may be worth you muting your mic, your side, while I'm doing most of the presentation, as otherwise I can hear an echo and you may get the echo of an echo, and it'll all be distracting. But
yeah, I'll try and do that.
So today we'll be looking at C#7. I have to admit, I don't know C#7 as well as I've known previous versions of the language by this point in their life cycle, as it were. So for C#6, I adopted that for Node time sort of 9 months or so before the language was released. With C#7, because of the way that Visual Studio 2017 is tied to the MS Build version of .NET Core things, whereas I'm currently using project.json for Node time. I haven't yet gone for all the C#7 goodness. And it's also not clear to me yet exactly where I'll use it within Node time, where Node time is usually my playground for investigating new features. Where C#6 was somewhat syntaxy based and making it easier to represent existing ways of doing things, C#7 is more, I would say, around how we use data. So you can see the list of the features we're going to talk about today, and a lot of it is in how data is composed together and how it can then be decomposed, where decomposition can be simply deconstructing one value into several or matching patterns against several different kinds of values. There are some features that don't fit into that description at all. So things like local functions and reflocal and refreturn. And I'll warn you now that refreturn, I don't properly understand either the use cases, which I think are mostly for the gaming industry, or the exact rules and nuances. Reflocal is slightly more understandable. And custom async return types is sort of an extra feature. I won't say bolted on as if it's sort of a wart on there, but it was a feature very much for the ASP.NET Core team, I believe, to have a value type for a task. But I'll run through that. Hopefully I'll get as far as custom async return types. If we run out of time before we get there, then for the most part, you can probably not worry too much about the details. However, I think you will be more likely to use the first few items here, which is why I've put them to start with. Okay, let's start with tuples. So I've only just realized I've been looking at the Hangout instead of my screen, as it were. So tuples, I'll just describe the types to start with. And you may also hear them called tuples. I don't have a particular axe to grind about how they're pronounced. Tuples are basically a bag of fields, and it's important to think of them that way because they are mutable value types, which is a scary deal to start with. I've always tried to make the value types that I write immutable, and I would never expose public fields. Tuples are the exact opposite. They are value types with public fields. So let me just create a Scratchpad class just for random doodling. So we get value tuple from a NuGet package. At the moment, I would imagine that it will be part of a future version of .NET, and I would expect Net Standard as well. But at the moment, it's just a separate NuGet package, and it's very simple. So we have public struct value tuple t1, t2, for example. I can't remember, the team were discussing whether or not to have wumples and nuples, which are tuples of one item or no items, which are kind of pointless. They would only be there for symmetry. But the value tuples are largely So those are the most important bits. They override to string, and they have structural equality and other equality, but this is the basic core of it. And this is scary because here is a public field and it's read write. So if that sounds scary to start with, think about reasons why we like value types to be immutable, and a lot of them come down to avoiding surprises when boxing and things like that, and implementing interfaces and places where mutability would be very surprising. If you instead think of every time you have a value tuple, you basically are declaring multiple fields at the same time, then it becomes easier to think about and not as worrying in terms of the mutability side. So that was certainly something that screamed out to me to start with, was what on earth are they doing having mutable value types? But it makes sense. If those were properties instead, sorry, they are item 1 and item 2. If they were properties, that would be badness for all kinds of reasons, that then you'd have to have assignments, and they wouldn't be feeling like a bag of variables, but it really is like a bag of variables, just like an array is a bag of variables. You can pass an element of an array by reference, for example, whereas you couldn't do that for an element of a list of T, because that uses an indexer instead, and it really is a wrapper around things rather than, hey, it's a bag of variables. Okay, so so much for what the type is. You'll have seen that it has item 1 and item 2 as the names, and one of the problems with the regular tuple of T1, T2, etc. that was in earlier versions of .NET, as well as being reference types and therefore requiring an object on the heap, which means that you'd often avoid using them for performance reasons. That had item 1 and item 2, item 3, etc. as well, which made them really hard to use. If you returned a tuple of string int from a method, for example, you would need to have documentation saying, well, item 1 means this and item 2 means that. In tuples in C#7, some information around names is propagated. So it's easiest to show you. You don't have to have names. We can construct a tuple using this syntax here, just values in brackets. And this is one reason why a womple is probably not going to happen, because, well, you know, that's just an expression that's in brackets. That is just 1. So the var here would show that it's an int. You can construct a tuple just by giving the values in brackets, and then we get item 1 and item 2. You can explicitly call the constructor, and here we're specifying an int and a long. The var here will do the obvious thing. In fact, IntelliSense is even showing, or Visual Studio is even showing it as the values in brackets, but it is equivalent to value tuple int equals whatever. More interesting is when we start giving variable names to the individual items. So here we have a name of A and a name of B, and then we can refer to those later on. Now, importantly, these are not part of the type itself. So whereas you might want, and if you had, say you had var anon1 equals new, name equals John, age equals 40, and then var anon2 equals new, address equals Reading, let's say, and I don't know, house number equals 36. I can't do anon1 equals anon2. They are different types. Yes, finally, we get the red squiggle. So these are entirely different types, and there's the name is part of the type, effectively. Each of these declarations ends up getting the compiler to create a new internal type. Whereas when we're using tuples, the only types involved are value tuple that are provided. So the compiler isn't generating any new types for this. It is generating some metadata, at least it would for methods returning tuples with names, which I'll come on to in a sec. But this is really just a tuple with syntactic sugar for managing the names. We could do tuple different names, C1, D1, and then tuple different names equals tuple 3. And that will compile with no problems at all. I think I'll probably show that later on in a separate example. So the names are really sleight of hand, let's say. You can specify the name in the declaration instead. But if you want to explicitly declare the tuple type without names, then that's the type and extra information for the variable. The difficult thing is, without a C#7 specification to refer to, I'm not quite sure how to refer to the type of a variable. So the type of tuple 3 sort of includes the A and the B parts, the names, even though that's not really in the type system. So some new terminology to get used to, but I don't know what that terminology is yet. Here we've got green squigglies because even though we're assigning a tuple with names to a variable, that variable has different, well, it has no names, and I could do different names and we'd still have the warning here, and even if I use the same names. Oh no, the warning goes away if you make the names agree. But really, why would you want that that redundancy? I would almost certainly use var. I don't know about all of you, but I've certainly been finding that var is much more, I've been using it much more widely than I expected to a long time ago. I used to be quite nervous about it, thinking, well, I really, really want to know the types up front all the time. And I found that actually I do know the types, even if I'm using var. Particularly test code, I tend to find has small chunks of code, so it's easy to tell the types anyway. So that's some examples of constructing. You can also use implicit conversions within construction. So I was looking at this just before the meeting started. So here are some examples, and basically we have element-wise conversion. So most of these probably wouldn't surprise you. You know, we can convert from 10 and 2 to longs, fine. We can convert from the constants 5 and 10 to bytes. If we put 1,000 here, that will no longer compile, I suspect. Yep. Whereas we and likewise, we couldn't have int x equals 10. That won't work. But this will, because there is a conversion from int to long as a sort of type conversion. There is only a conversion from int to byte when it's a constant expression which is known to be in range, and x isn't a constant expression. Those. This is possibly more surprising, is that you can do the conversion on assignment. So assigning a tuple of one type to a tuple of another type, well, even assigning a tuple of one type to the same type is effectively copying individual values. It can't just be a reference copy, because we've got value tuple is a value type, so it's copying all the elements, and the compiler just allows you to do this with conversions as well. Unboxing won't work, so if we do object boxed, I hope this is right. Do you know, it's just occurred to me this is using the wrong thing. There we go. Right. I originally had integers having a long and an int, and then this made it simpler. If we box the integers and then double, just bar, or just, we can reuse doubles. Double, boxed. So that compiles, but now I would expect, and I haven't run this code. It's just occurred to me you can only see Visual Studio, so you won't be able to see the output that I'm having now. That's probably not going to be a problem. I can just describe the output. It's coming up on a separate console window. But if I run tuple conversion, right, I do get an invalid cast exception. So this will just as you can't unbox from a long to an int, you can't unbox from a tuple of one type to a tuple of a different type, even if you could do an assignment that would do the conversions in line. And even user-defined conversions are available. Okay, so you can do other things with tuples beyond just declaring them and using them. And I've not used any of the values here in our original construction. I printed out A and B. What I haven't shown yet is that because they're mutable, you can do tuple 3.a equals 10. The mutability is fine. Let's have a look at actually using this. So tuple, name tuple 1. Somewhere I have an example. Let's just create one. Returning tuple. I'm sure I've got an example somewhere here, but I end up losing them. So let's come up with something that will take an IEnumerable of items, integers, and it will sum them and count them. So we can do int sum, int count, sum and count, IEnumerable int integers. And there are different ways we could do this. What we could do is let's start off with a result, and we can do sum 0 and count 0, and then for each value in integers, result.count plus plus, and result.sum plus equals integers. Sorry, plus equals value. And then we can just return result. So we can then have, and obviously, if you had an array, you could tell the count and then just find the sum separately anyway. But imagine this were, in fact, let's make it a little bit more interesting. Range 100, select so this is a lazily iterated sequence, and in fact we'll prove that. Sum and count equals sum and count values, and we can just write out the result dot, and you see we get IntelliSense telling us that we have sum and count available. And then we can call this again. And now if I run this, again, I will just describe the output. So the first time we had a sum of 493 and count of 100. Second time we had sum of 443 and a count of 100. So it really is working. It's lazily evaluating our link query. But the important part here is really that we can return a sum and a count. Now that's one way of doing it. We could just have int sum equals 0, int count equals 0. And that's fine too. Let's call that sum and count too. So that's just a different way of working. And they're actually kind of equivalent. There might be some very subtle differences, but this variable here, we've effectively declared two variables, sum and count, because it's a value type with public fields. There is no logical difference between declaring a tuple with two fields versus declaring two local variables. They are independent local variables, and it's just that we're returning the tuple directly versus creating a new tuple from it. But in every case, it's copying the values anyway. Okay, let me just see. Sorry, I'm consulting my notes to see what else I haven't mentioned. I will show tuple deconstruction in a minute. Tuple fields, yes. So this is one area where you may want to use tuples. I've so far just described what tuples can do for you, but without sort of why you would want to use them. And I think to start with, I would recommend using them only for either within a class or at least within an assembly. I would initially start off not returning them from public methods, just because if you do, and the prevailing wisdom becomes that that's a bad idea, you can't undo that. Whereas with backward compatibility things, it's fine to change a private method or an internal method and redeploy later. One thing you can certainly do with them and not affect your API at all is to use fields. So how often have you wanted to have, say, an address that's got street name and country and zip code, whatever, and you thought, well, I only need that composition of values in one place, and I really don't want to bother creating a new type for it. On the other hand, I don't want to have several separate fields declared separately. So where you might have private string street address, street name, private string int house number, private string zip code, and you think, well, I don't really want them being top. There's no grouping of those together. Where now you could do private string street name int house number string zip code, and now you could just refer to address.street name, address.house number, and address.zip code. And this should usually be a case of, well, I would want to use encapsulation a bit more, but just for the moment, I don't care too much. A little bit like we use anonymous types in link queries. And you can think of tuples as a sort of extension of anonymous types in terms of they are temporary compositions. It's not like they actually go away again, but they're focused to, I only want to care about this composition within a particular context. And that's where I'm suggesting that maybe if the composition might change at all, you really don't want to have these as public return types, but it's fine within your own types. So here where I have a field called counters instead of addresses, and you can see obvious things happening. We can increment both counters, we can increment one counter, and it's as if counters.x was its own field and counters.y, I've just noticed big typo, was a separate own field. I'm just going to switch over to the Hangouts to make sure that everyone can still hear me and everything. It's very difficult giving a talk with no feedback, which I understand I asked you to switch the mic off, but it can be very tricky. If anyone does have any questions, I will just, there's one more bit on tuples that I wanted to look at. One example, getting rid of out parameters. So methods that currently have out parameters, ignore the implementation, but imagine if trypars returned success and a value. And you might decide that you wanted it to be int value bool success instead. If you're familiar with Go, that will be a very familiar way of doing things. It means you can't see what the problem is if there's any problem doing the parsing, but it's nice and simple. Okay, I think that's it on tuples. So I will just pause for 30 seconds to see whether there's any questions. I will be, if you're wanting to see tuple deconstruction, I'm going to come on to that in terms of deconstruction in a minute. but anything else on what I have covered? Okay, I will assume that that's a no. Okay, so tuples are to do with. Oh, sorry, go ahead.
No, we're good. If we do the next thing, and then we might have a quick 5-minute break.
Yep, that's fine.
Yep. All right.
No problem at all. Okay, so deconstruction. So tuples are to do with gluing together values, and the obvious other thing that you would want to do is deconstruct them. So there are a few different aspects of this in C#7. Let's stick with tuples for the moment and have tuple deconstruction. So here we have a method similar to what we've already seen called create tuple, and it just returns a tuple. So this should now be entirely familiar. You could do this in your sleep. The new bit is, instead of doing var tuple equals create tuple, I'm doing var abc. So this gets the tuple that we've had back from the method and declares 3 separate local variables called a, b, and c, and they are just entirely different variables now. And you can ignore the fact that they came from the tuple, and you can also assign to existing variables C has to be a string. There we go. I don't think you can declare. No, you can't mix and match assigning to existing variables and declaring a new one, as far as I'm aware. You're either assigning, deconstructing to 3 existing variables or declaring 3 new ones. There may be some subtlety that I've missed there. We'll find out when there's more of a language specification to look at. Okay, so once you've got the idea of deconstructing, and with tuples being the obvious thing that you would do that with, you might think, well, I want to be able to do that with other types as well. Partly because sometimes you will start off using a tuple and then think, do you know what? I actually want to be able to get to more nuance, and I will add an actual encapsulation and add some behavior, but I still want to be able to do this. Well, you can, for any type you like, using a new special method called deconstruct. So here we have a perfectly regular class. So this would compile in C#6, this part of it would compile in C#6 with no problems. It's just a class with some properties and 2 overloaded methods called deconstruct. And the deconstruct methods, I suspect pretty much all deconstruct methods will look a bit like this. All we're doing is assigning to X, message, and E. And the new part is that we can then use those to deconstruct into existing variables. So we're creating a new instance of deconstructible and then assigning to new variables. So this could have been returned from a method, whatever. Yeah, this is just an expression of type deconstructible. Or we can use var and deconstruct into 3 variables or 2 variables, and it will pick the right overload. One interesting thing you might consider is, imagine I want to do this using an expression bodied member. We can actually use the fact that you can deconstruct tuples to do X message equals X message. So this basically just creates a tuple of X and message and assigns it to the lowercase x and message, which are our parameters. I have no idea what the performance implications are. but if there aren't performance implications, that could become quite an idiomatic way of doing things, because then it's fairly obvious exactly what's going on, and that this method, one thing I like about expression body members is that it's obvious that this only does one thing, and it so happens that the one thing it does is copying multiple things from inputs to outputs, so from our properties into our out parameters. You can also use this same trick for constructors, by the way. So you could have deconstructible exception error, and I've previously only shown deconstructing to local variables, but you can do x message error equals x message error. Exactly the same as this. So we're building a tuple, and this time we're deconstructing to the properties instead of to local variables or out parameters or whatever. I will just remove that for the moment, partly because it breaks all the rest of my code. So we can deconstruct to existing properties, existing fields. Do you know what? Let's try something interesting that I haven't tried, which is, let's do copy to a deconstructible other, and I wonder whether we can do other.x, other.message, other.error equals this. Wow, we can. Right, so I love giving this kind of talk on something where I don't know the details terribly well. So this is a property of a different object, and we're using the deconstruct method here to assign these values that then immediately get copied to other. And that means we can do that in an expression body member, of course. And that's kind of cool. I would urge caution around this language feature for the moment, just because, again, until we really know how useful it is in various different contexts, let's sort of be somewhat cautious. I could see it being abused. I suspect that there aren't too many problems in terms of performance, but you know, anything you're doing that's performance sensitive, I hope you're already measuring. There's one interesting thing around this. I've shown you the deconstruct method. What if you're trying to deal with something that doesn't have one already? Well, deconstruct is pattern-based, so you can use it with extension methods. So here I've got a local date. It's part of node time, so a little bit like date time, but only has a date. And I've got an extension method on it called deconstruct. Eventually I will put this into node time, I'm sure. And so we can deconstruct to the year, month, and day. And if I just do today, in fact, I can show you, if I do today.deconstruct, that's shown as an extension method. I don't know whether you can read, that's in a fairly tiny font. By the time it's gone over a Hangout, I suspect you won't be able to see, but it's showing that it is an extension method, but I can still use it for deconstruction. So here I'm just declaring variables ymd. Obviously, I can't just do var deconstructed equals today, because that's just saying deconstructed is of type local date. So I don't think there's any obvious way that I can infer year, month, and day as names here. I have to give them names, but I can do I can use var so that I don't have to specify the int part. So deconstruction works with extension methods as well as regular methods. And now final part of deconstruction is sort of similar in terms of its matching aspects of a type. So in this case, it's matching deconstruct as a method name and tuples In fact, tuples don't have a deconstruct method. They are just deconstructed by the compiler itself, at least as far as I've seen. So if we do var tuple equals 1, 2, dot deconstruct doesn't exist, even when I type it properly. Out int x, out int y. That's another feature that I haven't shown you yet, but it doesn't work anyway because deconstruct doesn't exist. Well, yes, it thinks that we're trying to call local date.deconstruct, slightly bizarrely. So tuple deconstruction doesn't use the same aspect of the language. It's got its own deconstruction bits. I'm not quite sure why they did it that way. They could have implemented it with the deconstruct method, I'm sure, probably for performance. However, if we want to go a little bit more general, there's pattern matching, which I'm sort of, does it count as deconstruction? Who knows? But it's similar-ish. So let's look at a couple of ways you can do pattern matching. Firstly is in if statements, and second is in switch statements, which I'll show you in a minute. So we're used to using as and is and casts. So if you've got an object like this and you want to know, is it a string, and then use the string, you might previously have done string temp equals x as string, if temp not equal to null, do stuff with temp. And that's ugly because it's got the scope of temp is in is the whole of the rest of the stuff. So we really want something that is scoped to just the if statement. Well, we could do if x is string temp equals string x, and that's a bit inefficient. We've got the scoping that we want, but it's a bit inefficient. This is sort of what you have to do if you're using value types, unless you do, you could do int temp equals x as int, and then if x not equal to null, and then you can use temp.value. That's insanely inefficient for reasons that I have never quite understood, but it just is, and it still has the problem of the scoping aspects. So it's not uncommon that we want to be able to match by type and declare a variable of the right type only if it matches. And pattern matching with an if statement works exactly that way. And console.writeLine I, nope, that's not in scope. Scope is kind of important, and there have been some interesting scoping discussions for C#7 for similar features, which I will come on to later around out parameters. But here, yes, the scope of I is what you would want it to be, which is only within the if statement. Okay, but you don't just have to match against types. You can match against whole values. So this is kind of pointless in a way. So if x double equals 5 would not work. Sorry, it would when x is an int. If we make that object, that's still going to work. And in fact, sorry, yeah, that's my next example is this. So here we could do that, and it's still going to do exactly the same thing because it will do an integer comparison. If I do it here, then that's not doing what I want it to be, and it won't even compile because you can't compare between between object and int. You could do x dot equals 5, but then that's going to be wrong if x is null. You could do if 5 dot equals x, and that's just really ugly. and may involve boxing the 5. I'm not sure. I believe that this is check that the type of X is int, and then check it for equality in the obvious way. Again, without the language spec, I struggle to know exactly what this pattern match does, but that will become more obvious over time. And there are details of a lot of this stuff on what used to be the Roslyn repo. I believe language design has moved now to another repo, but it's still on GitHub, and I'm sure there are still links from the Roslyn repo. So you can find out more details. I would urge a little bit of caution for this, in that there are quite a few design docs and things for things that haven't been implemented or were implemented and then changed. So there's some old stuff. There are lots of issues that describe features that are wanted but not implemented yet. Ultimately, what works in Visual Studio 2017 is the real test of what's going to happen. So finally, before we break, I've shown if statements. Well, you can also use pattern matching in switch statements. And here we've actually got another case, which is the when clause. I'm just going to check when I above 5. No, so when clauses don't work in if statements. I think they're a switch statement only feature. But basically, switch statements, instead of switching on constants, you can now switch on patterns. So this is like our X is 5, apart from before. We can match on the type and then do some check on the type. So this is saying only come into this when Y is an integer, and then apply this guard clause, I think they're called. They certainly were at one point, to check whether the value is odd. And as I say, odd numbers other than 5 always blend. Now, the other than 5 is important here because, unlike switch statements in the past where the order of them almost never mattered, there's one bizarre case where you declare a local variable I'm not going to go into. But now, this switch is just syntactic sugar for if, else, if, else, if, else. So it checks whether it's 5, then it checks whether this case is true, then it does the next one. Here we have another variable called y. So this has a different scope from this, which is unusual in that normally the scope of a variable, a local variable, is the block in which it's declared. Well, not when it's declared in a case statement, which sort of makes sense for the if. The scope of I is not the block in which it's declared, because it's declared within this block, not within this block, but still the scope is the block. So similarly, where we declare y just for this this block, we've got two separate variables, and they could even have different types. So this is a third variable, and now y is suddenly a string instead of an int. And finally, we have our O. So O will just be declared of type object because that's the type of X. So this is effectively a default case. This is only the start of pattern matching. It's, as far as I'm aware, all that's available within C#7, but there are whole other patterns that you potentially could match. So let's see. Let's just A, B. No, this isn't looking good. Turn tuples blend. So I would expect in let's see whether, no, that's still not working for us. I would expect eventually this to work, and you could do when A greater than 5 and B less than 0 or whatever. So this would be a deconstructing pattern. So not just matching individual bits. Sorry, not just matching the whole thing, but matching individual parts. And eventually, I'd even expect case A0 to work. So if you're a functional programmer, used to F# or Haskell or whatever, this sort of thing should be quite familiar as how you get work done. And in many cases, it's not going to be useful. There will be C# programmers who write complicated code who never need this. On the other hand, there will be some programmers who, because of the kinds of tasks that they do, this will be very useful indeed. So that's pattern matching and the end of deconstruction in general. I am somewhat over halfway through talking about C#7, I think, but I think now would be a good time for a break.
Okay, thank you, John. So pizzas are here out in the kitchen. So if you want to quickly as you can, grab a couple. We've got some plates. Get a refill of a drink if you need, and then come back, and then we'll get back into part 2. So.
I'm not going to use it sort of like that, and it's confusing.
I'll bring it back, please.
Oh, I like what you're saying. You don't really want to expose it as effectively that compile is just in value for A and B, and it will literally cover it, get exposed as item 1, 1, 2. So there's no. It's
George, you're right. It does sound a bit like Steam Ramps.
Yeah. I keep Stephen. Anything that guy sounds like
Oh yeah, yeah. Trying to get some people understanding both software and hardware. Wow. But anyway, that's
Pretty different. You can do those functional,
it's just maybe
those expressions.
I just didn't see it. Because what they do really is like how can I say it? Someone just can do like understand multiple tech stack and they really just put good block together. Now here. Yeah, not that hard.
I think there's a couple of 17s, but 4 of them are trying out.
Alright.
Yeah.
Thanks everybody. Normally we would eat at the end, but this way the piece doesn't get cold. So we're feeding your stomachs and your brains. So. Okay. Well, John, if you're ready to.
Yeah, my pizza hasn't arrived yet, so
Yeah.
Time zones.
I will go and get some toast after this.
Okay, I'll mute our end.
Okay, right. So let's look back at the agenda to see what else we're going to look at. So we've got, in fact, I included pattern matching within deconstruction. So we want to look at out parameters. That would be fairly fast. Local functions, ref local and ref return, which are a bit crazy. Numeric literals and custom async return types. So even though we've only looked at the top 3 of these, they are the bulk of the description, and I would say the bulk of what you'll use. So out parameters are really quite simple. So basically, where you used to have to declare a variable first, so you would have int value old style. Let's call this value 1, and then we'll have value 2 here, and then value 3 here. So you used to have to write out value 1, then no news, value 1 is still in scope. So this used to be a problem, not only because we had to declare it beforehand, but also because of the scope. Now, you might expect, given what I've said, for it to be better for value 2. But this is still the same problem. So, unlike pattern matching, where we had we were introducing a local variable within an if statement, when you introduce one using an out parameter, that does keep its scope, which is entirely reasonable, because suppose you actually wanted scoping is reasonable. Maybe we actually have if we don't, something is wrong. Well, just because it returned false doesn't mean that we don't have access to it. Value was 4. Additionally, we would have to know that the not operator, or we'd have to know that try_parse returned true in some cases and false in others, and what that meant. Otherwise, it's entirely reasonable that an out variable, an out parameter is useful regardless of the if in question. Whereas if I go back to pattern matching, if x is int I, if that fails, then int I just isn't anything. So the scoping rule, it would be bizarre for I to have any value here. Whereas when we're using out, it does make sense. Where scoping changes slightly, or other a difference, is if we have int.try_parse foo out int value 5, got lots here now, and int.try_parse bar out int value 6. Both parsed. Now we can write console.writeLine value 5. Fine. Can we write value 6? No. And it's not because it's not in scope. It's not definitely assigned. So that's as if we had written int value 5, int value 6, and left out the int parts. We would have 5 is definitely assigned because we know we'll always be calling try_parse the first time, whereas we might not be calling that one. So the compiler, and this is rules going way back, the compiler knows that value 6 isn't definitely assigned, but it does exist. Invalid because value 6 assigned. Value 6 equals. Okay, and the other aspect to mention is you can use var with out parameters. Obviously, that has to then do overload resolution. So if you had two methods that were overloaded and only varied by the type of their out parameter, then this would be ambiguous, whereas outint wouldn't. And that's kind of all I have to say about outint. Out parameters declared in line. It does help you if you've got if you want to use method bodied expressions, expression bodied members. So we could have public bool that does it parse x. We could just do int.try_parse x and then out int ignored. We don't care about the value at all. Or even parse with default value. Put that into a different why isn't that working? Oh, because of the return type. That's fine. Okay, so here we have a single expression, and this wouldn't have been feasible in C#6 because of the out parameter. We would have had to declare value first, and it's fine to return value because it will be definitely assigned after this expression is evaluated, so we can use it as normal. So that's just one other place where you might want to use out parameters handily. I think it's mostly, given that it doesn't help, unlike the pattern matching, it doesn't help with scoping. It's mostly just a bit cleaner than this, but it will definitely help for either expression bodied members, or if you want to do static read only int b equals int.try_parse, this exact thing. value, outint value, value 20. That's, oh, that doesn't, well, that's me told. The compiler is saying out variable and pattern variable declarations are not allowed within constructor initializers, field initializers, or property initializers. So you couldn't do it there. You could use that as an expression if you're calling another method, not within an initializer. But if you had it within here, that's useful to be able to do something. So call some method, and you want to just be able to do everything within one expression. And yes, value is still going to be out. The scope of value is going to be too wide, but it's still convenient. So this is really just a convenience little feature. There's a possibility that certainly something that has been discussed is if you really don't care about the value, how does it parse? Parse string text. Input try parse text star. So no, with a space, and this is probably why it hasn't happened. And it might even be that it was meant to be that. It doesn't work in the release candidate, which suggests that it won't work for C#7. Maybe they'll put it into C#8. But the idea is basically to indicate this is an out parameter that I don't care about the value afterwards. So do whatever you like. It's fine. I would normally just do outvar underscore. I tend to use underscore for, yeah, I don't care about this value. And I do the same thing for lambda expressions if I don't care about the input. So I may already have done it in, when did I use link? In the, I've now found my examples for sum and count. But returning tuple, I had this. So select underscore. Right, and now I know that I can delete returning tuple later on, given that I have the 3 summings. Where was I? Yes, so out star doesn't exist. I'd suggest just using underscore as meh, I don't care. Right, next feature I think was going to be local functions. Yes. So local functions are literally a matter of being able to declare declare methods within another method. And where have I got local functions 1? There we go. So here is an example where we're doing the Fibonacci sequence, and I don't want to declare this as a private method elsewhere. I only want to use it within main, and I can do so. Now the rules around locations, I can do that wherever I want. If I do sum int x int y, for example, I could do sum fib like that. So you could have methods that call each other, whatever it is. One useful feature is that hopefully, as you'd expect, you can refer to local variables within the method. So here's an example where I certainly suspect it will be useful just to make a previous annoying pattern nicer. So suppose we're implementing anything that uses an iterator block. So an IEnumerable of t, and the same is true for async as well. Now, these are lazily evaluated, or the async version wouldn't be lazily evaluated so much as it will return a task or task of t or a custom one in the future. But any exceptions will be sort of embedded within that task. So if you have some argument validation that you want to provide, so this is in the case of iterator method. Let's see if I've got, I don't have an async example, but the same kind of thing would apply. Imagine this were an async method. You really want null argument null exception to happen immediately. You don't want to wait for someone to await the task, because the further away the detection of the problem is from where you actually found it, where you first discovered it, the harder it will be to diagnose. So for argument validation, I want that to generally be as eager as it can be and throw an exception immediately. Aside from the async case, in the case of select, so select broken, I can call select broken with null, null. So let's do int. Let's just move this up to here. And we can just have broken. So I don't like the fact that this doesn't go bang, but this is the implementation of select in the most obvious way. So I throw an exception, but those are only going to actually be thrown if I start using them. Let's have a look at one way of doing this better. So it used to be, let's do select, let's copy this. And the old way of doing this, select old school, and then we'd return select old school impl source selector. And let's just copy the whole method again. So we end up breaking the method into two, and it's really annoying. So select old school impl, and now we don't have the argument validation. So we've effectively got sort of one method that's broken by a return statement. And the reason for that actually having an effect is that this is no longer an iterator method. And just like if we were doing async, we wouldn't declare this as being an async method. It would return task of t, but only the implementation bit would be an async method. So basically, we only get to the lazy evaluation after everything's worked. So what does this have to do with C#7? Well, we can have local methods. So now we can keep everything in the same place and declare our local implementation method and then just return it. And another alternative, which is slightly more efficient, would be to declare it with parameters again and pass in those parameters. So the reason this version is slightly more efficient is it doesn't need to create a new object. I don't know how much any of you know about how Lambda expressions work and things, but basically when you capture in a Lambda expression local variables, including parameters, then the compiler has to generate a new class for you. And that's exactly what happens here. So basically impl will be created as a method within an anonymous inner class, effectively, that has source and selector, and the compiler will create an instance of that class and then call the method on the instance having specified the variables. So that's slightly less efficient. This is a slightly more efficient version. And that's, I think, all there is to local functions. I think use cases, we will find use cases as we go. I would point out one interesting aspect of fib is this calls itself. Let me do a non-local variables version. So you may think, well, surely declaring a method is just like declaring a function. So we could try doing func int fib equals n goes to And it sort of looks good until the compiler says no, and it's saying, well, it's an unassigned local variable, and it is indeed. We have to do that. At which point that now does work. And you know, maybe the language rules could be changed in terms of use of unassigned local variables within Lambda expressions, but it's kind of nicer just to be able to declare it as a local function, because that's really what we want. And this allows us to use iterator blocks, as I saw in the select impl, where I don't think you can use. Let me just try this. Func enumerable string x equals nothing goes to yield return when I've pulled in system.generic. No, you can't use Lambda expressions within. Sorry, you can't use yield statements within Lambda expressions. So even if things have worked so that fib would work, the func here wouldn't work. So those are a couple of reasons to use local functions. Do not expect to use these all over the place. Or I certainly don't expect to use them all over the place, but they could be useful in a few little bits and pieces. Speaking of things that we're not going to use terribly often, let's look at reflocal and refreturn. I can imagine using reflocal not very often, but I expect I will use it. Refreturn, my guess is I will never use it other than to demonstrate refreturn. Let's have a look at what reflocal is. So both cases are ways of using reference variables more widely than they can at the moment. So just as an introduction, if we have static void foo ref int x ref int y, and then we call, I'm not going to use it, but int z equals 10 foo ref z, we've got now 3 variables, z, x, and y, but only one storage location. So every time we use x or y or z, we're referring to the same data. So I tend to think of variables as like a sheet of paper with a name and a type on the top and a value written on the sheet of paper. And this is a sheet of paper with 3 different names written on, x, y, and z. Okay, so with that background, what does reflocal look like? Well, reflocal allows us to take a part of an array. I mentioned before that arrays are basically bags of variables. And it's possible that you can use reflocals for other things like bits of tuples. I haven't tried yet. But we can say ref big struct reflocal is ref of array I. And that's saying, well, I don't want to make a copy of array I itself. I just want to have a variable which, wherever I use it, will refer to that part. So create a copy, not what we want. Big struct local equals array I. So if I modify local.a++ doesn't affect array. We could then do array I equals local. Let's just make this B instead. Copy into array. So this is what you would have to do before in order to affect the array in the use of a variable for other reasons. So you could write if array I dot x less than I, array I dot a++, and that's equivalent to this code. but it needs to evaluate array I. It will do bounds checking, etc., multiple times. It doesn't copy all of array I out. I've deliberately made an array of a large struct here. So we don't want to be copying that all over the place. And this achieves that goal, but it's kind of annoying. Imagine if you were using array I several times. The code here is effectively saying, just give me a variable which refers to the right bit of paper. So going back to my analogy of variables as pieces of paper, you can think of an array as a book. And the page numbers on the book are the element numbers. So array 0 is page 0 of the book. Well, what we're saying here is just write the name reflocal onto page I for the duration of this array, this iteration. And so wherever I say reflocal, consult the page. Don't photocopy the page and then I'll work with that, which is what this part here does here. That's sort of copying a page out, doing some work on it, and then copying it back. This is saying, no, when I say reflocal, I mean that page. So modify things on there. If you're not dealing with large mutable structs and arrays of them, this probably won't be terribly useful. Just occasionally, that is a useful thing to be able to do. It helps you with locality of reference, all kinds of bits and bobs. I will just silence my phone. Try again. Sorry, where was I? One of the downsides of working from home rather than, or presenting from home rather than presenting in person. You never know when the phone's going to ring. So that's all there is on reflocal. If you are games authors with Unity or whatever, it's much more likely to affect you. And I gather that is also the case for ref return. So if you can get your head around reflocal, ref return is even stranger, where you can pass back a reference to a variable as a return value. It's a return variable rather than value. I think this is going to be quite strange, but we'll see how we go. So the example that I've got here, we have two variables, A and B, and our getRandomVariable method returns either a ref to X or a ref to Y, because those are the parameters. And then whichever one is returned, we increment. Okay, so after I've run this loop 20 times, A plus B will definitely be 20, but it could be 10 and 10, it could be 5 and 15, anything like that. And let's just see. Fx. Oh. Y. So if we replace the method body with this, nope. By value returns may only be used in methods that return by value. File, conditional operator and ref local go together. It's quite hard to work out what the type is here. So what I can't do, this increments one of the variables. What I can't do is say x equals getRandomVariable x plus plus. Has no effect. X is inferred to be an int. Copy of value of A or B. So effectively, there's no benefit. There's no, the fact that it's returning refint is irrelevant here. And this is where the increment is lost. it'll be. So I don't know how you can use the return of get random variable other than directly as if it's a variable. My guess is you could probably pass it by reference again and things might happen. But I will be staying away from this feature mostly because I don't need it, but also because I think it's going to make life much harder to read. That's all I have to say about ref return. Let me just introduce an extra bit into the agenda. You'll see that all these features, apart from custom async return types, which is complicated, these are fairly simple to describe. Throw expressions will definitely be useful. It's as simple as throw used to be a statement, it's now an expression. Job done. So this used not to work. You couldn't use throw just as part of another expression. And the other time that I sometimes want to do this is do something string x. Used to do things like return x is foo, n x is bar 20, and then what do you want to do in the default case? Oopsie, throw new argument exception x must be foo or bar. Okay. That used not to work. You would have to use if, etc. Of course, we can now use switches for exactly this. So we can use pattern matching, which has always been fine to have throw anyway, just because it's a statement in the case. Nothing more to say about throw. If you do, you can't use throw with var. Var y equals throw new argument expression. So a throw expression is not allowed in this context. Not sure whether it's no. So there are clearly some rules where it's only going to be allowed in cases where it makes sense. And again, I haven't looked at exactly where those cases are, but if you try to do sensible things, you won't run into it as a problem, basically. Let me just make this into a nice... Some people don't like this use of conditional expressions. I think it's a really, until switch case is prevalent, I really like it. Could use switch case. Length. Let's do something that would actually need more than previous ones. So that's all to do with throw expressions. I sort of apologize for this talk is a bit of a random one in terms of it's such a grab bag of features, but I'm afraid that's how C#7 is. It was much easier to describe sort of C#4 or C#3 because they had this overarching theme with a couple of bits and pieces extra. C#7, well, there's the data decomposition stuff, which pulls together a bunch of features, but then there's other bits and pieces that have just been put in. So next up is numeric literals. And this is as simple as looking at these 3 lines of code. So there are two features here. One is that we can have binary, hooray! That's really useful. Another is that we can have underscores anywhere, and it is anywhere. So we can have lat equals 100,000. So where we put digit separators in for thousands, some Indian languages have this concept of a lakh. which is 100,000. I don't know whether they actually use them in digit separators, but yeah. I would imagine it's feasible. So you can put digit separators wherever you like. I think you can only put one at a time. No, you can do what you like. You don't have to be consistent or anything. It doesn't make any difference to the compiler, and they are just ignored. One place you can't put them, which I would like to be able to put them, is immediately after. Oh, no, I thought for a second that they'd fixed it. I would love that to be valid because I think it looks considerably clearer, but it's not. I've got a feature request on the Roslyn source, maybe in C#8, who knows. So it just makes numeric literals easier to read in some cases. You can imagine, you know, if you wanted to separate out nibbles of a value, certainly if you had some 32-bit binary value, then doing it at every 8 bits would be really useful. And that's numeric literals. Finally, assuming I haven't forgotten some features, which is quite easy to do with C#7 because there are so blooming many of them, is async return. There are two halves to this feature. The overall feature is async methods in C#6 could only return task of T. In C#7, or sorry, task of T or void or task, and you only return void for event handling. In C#7, you can return your own type. So in this case, custom task that has to obey some rules. Now, the exact rules, this is code that I was given basically. So the type has to have an async method builder attribute, which is provided here, and presumably it will be somewhere in the framework, which is used to say, well, what builder do I use to construct one of these things? And it has to have a bunch of methods on it, like set state machine and start and set exception and things. You're not going to need to do any of this stuff. So lines 39 to 103 of this example are almost certainly going to be irrelevant to you. I would suggest that other than people who are interested in exploring the language and maybe doing nasty things with it, such as myself, most of them aren't going to care. What you will do is things like this. And instead of using custom task, you will use value task of T, which will be in the framework. And that is a struct version of task of T. And that's probably all you need to know is, hey, you can use value task of T instead of task of T. The background of how it's done internally, do you know what? I have mixed feelings around whether the language team should have designed it this way or should have just said, sure, let's introduce value task of T, put it in the framework, and open up the restrictions a little bit and make the compiler know about value task of T. This is definitely more elegant, allowing you to do kind of whatever you want. But as I say, vanishingly few people will need to write their own custom task. And that's probably a good thing because it's so easy to do wrong. So I'd discourage you from doing it unless you're an expert on this kind of thing. But the ASP.NET Core team will have provided value task of T, and in certain high performance scenarios where you really don't want the overhead of having an extra object on the heap for every method call, this will be very useful. I think that finally, and you've been very patient, I think that finally concludes the C#7 features. If anyone knows of any features that I haven't mentioned, the whole sort of scope of C#7 has been pretty fluid. So do shout out if there's anything that you think I should have covered, and I will try to write code on the fly and see what happens. Otherwise, any questions about or comments on the features I have covered would be good.
So any questions for John?
But your mic is still muted at the moment, I think. Or, sorry, hang on. Right. I must apologize. If you've been saying things for the last half hour or whatever, I wouldn't have heard them because, so I'm working in my shed. In fact, if I stop screen sharing, I'll show you where I'm working. and I have an amplifier, a surround sound amplifier, which had turned itself off because you were muted. No sound was coming through, so it went into power saving mode, and wouldn't have noticed if you unmuted. So apologies if there were any questions. Feel free to repeat them now, and I really wasn't trying to ignore you. I do apologize for that.
That's fine, John. Any questions? This is your chance. He's there on the screen. This is probably as close as you'll get to Adelaide. So.
Yeah, so I went over to Sydney in August, and I had my family. If I hadn't had my family with me, I would have done sort of a mini tour of Australia, I think. But I wasn't going to drag them everywhere with me, and half the travel arrangements had been made. So yes, apologies. I probably won't be there in person. Obviously, this was an hour and a half or however long it was of fairly intense. Here's a quick description. Just as a quick plug, I am currently writing C# in depth 4th edition. I've just finished writing the stuff about C# 6, where I kind of knew what I was talking about. I'm about to embark on writing the C# 7 stuff, so I will be finding out more. So by all means, buy C# in depth. Other C# language books are available. All the code for this is on GitHub. So if you look for Jon Skeet as me on GitHub, and then it's under demo code. And you can find, I will upload the changes that we've made during the talk, because they provide some more examples. I'll upload them shortly.
Okay. Well, last chance. No. Okay. Well, John, thank you so much for being so generous with your time, and
My pleasure. Thank you.
really appreciate that. It's been great. We've just had a great response here tonight. I think they're kind of stunned, actually. Just
Yeah. This is the downside of, I do tend to speak fairly fast, and especially if there's lag between me and you in terms of the sound and the IDE. It's not an ideal way of learning, admittedly, but I've certainly enjoyed it, and I hope you have too. And probably the best thing to do is work out which of those features you're interested in and try them yourself. Maybe clone my repo so that gives you a starting point, and then just start experimenting. Obviously, you'll need Visual Studio 2017. The release candidate is available now. I hope that within a month, maybe there'll be a full release. Who knows? It's certainly getting close.
probably this year at least. So. Yeah. So okay. Well, thank you, John. And I guess just we are recording this, so and I think John's happy to make it public. So
yes, no problem.
I'll probably edit out the pizza bit in the middle. And yes, but if you do want to go back and watch it again, I probably will do that just to go over a few things. But no, would you just thank John for his time? And,
And if you think of any questions afterwards that you wish you'd asked me, brief comments or whatever are fine on Twitter, but it's very hard to answer technical questions on Twitter. My email address is on my Stack Overflow profile, so feel free to ask me questions personally, or better, if it's something that would make a good Stack Overflow question, then just ask it on Stack Overflow, and then maybe ping me on Twitter or whatever, and I'll get straight to it. Obviously, I try to look at C# language feature questions on Stack Overflow, but it's quite easy to miss things, particularly with our time zone difference. So if I haven't answered it and you'd like me to look, then just ping me.
thanks, John.
Okay, thank you ever so much, folks. I shall hang up now. So I dare say there's housekeeping bits and bobs, but I shall let you do those in peace.
Okay, have
Bye,
a good
folks.
day.